Hello students, welcome to the subject of complex variable and partial differential equation. Myself Dr. Ankit Acharya, and as you all know that in last lecture we discussed about how to find particular integral for our case 3. Case 3 means polynomial x raised to m into y raised to n. And we already solved one example. Okay, so let's take a quick revision. In case 3, your particular integral is 1 upon f of d dash into f of xy, where f of xy is a polynomial. So first of all, 1 upon f of d dash you convert in this form 1 upon 1 plus x or 1 upon 1 minus x, where x is nothing but your function of d dash or f of d dash. Okay, and for that you have to apply this binomial formula. Okay, 1 upon 1 plus x, we know that 1 upon 1 plus x we can express 1 minus x plus x square minus x cube into 1. 1 upon 1 minus x, that is nothing but 1 plus x square plus x cube into 1. Okay, so instead of x, suppose you have f of d, suppose you have f of d dash, or suppose you have f of d dash, d into d dash, right? So let's solve this example. Del square z by del x square plus 3 del square z by del x del y plus 2 del square z by del y square, that is equal to x plus y. And as you all know that first we have to find complementary function. So what is our function? F of d dash, that is equal to d square plus 3 d dash plus 2 d dash square, that is equal to 0. So m square, I can write m square plus 3m plus 2, that is equal to 0. Don't forget to write m is nothing but d by d dash. So this can be written as m plus 1 into m plus 2, the factorization of this second degree polynomial, and the roots are minus 1 and minus 2. So that's why complementary function is nothing but f1 y minus x plus f2 y minus 2x. Okay, now I want to find particular integral. So what is my particular integral? Particular integral, that is equal to 1 upon f of d dash, so that is d square plus 3 d dash plus 2 d dash square into x plus y. Okay, x plus y, right? X plus y. Now d square, I can take d square, 1 upon d square I want to take as a common, so that's why I need here 1. Okay, don't forget, only I can apply 1 upon 1 plus x or 1 upon 1 minus x. So in denominator at least one term must be a 1. Okay, so you have to take common 1 upon d square, so that's why this term becomes 1 upon this equal to, I can write 1 upon d square 1 upon 1 plus, now what is the other terms? Okay, 3d d dash upon d square, so that can be written as 3d dash upon d. Okay, so 3d dash upon d plus 2d dash square upon d square, right? So 2d dash square upon d square x plus y. Okay, now this equal to, I can write 1 upon d square. Now apply this formula for 1 upon 1 plus x, that is nothing but 1 minus x plus x square into 1. So 1 minus 3d dash upon d plus 2d dash square upon d square. Okay, plus 3d dash upon d plus 2d dash square upon d square whole square, and so on. Okay, x plus y. Now we know that differentiation of x plus y with respect to y, only the first differentiation is 1. From second differentiation you will get all the values are 0. So from this term 2d dash square, because 2d dash square means what? Differentiation of this function with respect to y 2 times. So this term becomes 0. All other terms, okay, after this term also all other terms become 0, because here we have square. So this is nothing but d dash square, middle term is d dash cube. Okay, so all other terms are 0. So we can write 1 upon d square 1 into x plus y. So x plus y minus 3 by d d dash into x plus y. Okay, that means d dash into x plus y means what? Just I write d dash x plus y. So that means differentiation of x plus y with respect to y, and that is 1. So I can write 3 by d, right? 1 upon d square x plus y, okay, minus 3 by d, because differentiation of x plus y with respect to y, that is 1. So 3 by d, that means integration of 1 with respect to x. So that is x. So that's why x plus y minus 3x. So I can write 1 upon d square, this is equal to 1 upon d square x plus y minus 3x. Okay, x plus y minus 3x. So that's why in bracket now we have y minus 2x. Okay, 1 upon d square y minus 2x. Now integration of this function y minus 2x with respect to x 2 times, because we have 1 upon d square. So 1 upon d, I can write xy minus x square by 2. So this 2 become cancelled. So xy minus x square. Okay. Again integration with respect to x. So x square y by 2 minus x cube by 3. So this is my final answer, particular integral, and just write down the general solution, complementary function plus particular integral. Let's solve one more example. This is our next example. Del square z by del x square minus 6 del square z by del x del y plus 9 del square z by del y square, that is equal to 12x square plus 36xy. So f of d dash, I can write f of d dash, that is equal to d square minus 6d dash plus 9 d dash square. Okay, that is equal to 0. Now m square, I can write m square minus 6m plus 9 is equal to 0. Now don't forget what is my m. M is nothing but d by d dash, and this can be written as m minus 3 whole square, that is equal to 0. So roots are 3, 3. Okay, roots are 3, 3, repeated roots. So complementary function, I can write f1 y plus 3x plus x into f2 y plus 3x. Okay, now I want to find particular integral. So what is my f of d dash? D square minus 6 d dash plus 9 d dash square, 1 upon f of d dash. So 1 upon f of d dash, so that is d square minus 6d dash plus 9d dash square, d square minus 6d dash plus 9d dash square. And what is my function? Function is 12x square plus 36xy. So 12 will be common. So 12 I can write here, x square plus 36xy. So now I have 3xy. Okay, what is my function? Function is 12x square plus 36xy. So 12 I can take as a common term. Now d square I can also take common. So 12 by d square, this is 1 upon 1 plus 9d square d dash square divided by d square minus 6d dash upon d into x square plus 3xy. Okay, now simplify this term, 1 upon 1 plus x. I know that how we can simplify. So 1 minus 9d dash square by d square minus 6d dash by d, okay, plus 9d dash square by d square minus 6d dash by d whole square, and so on. Okay, what is my function? X square plus 3xy. Okay, and we know that differentiation of this function with respect to y from second derivative, all the terms become 0. So all this term becomes 0. So only we have 1 minus minus plus. So I can write on the next page 12 by d square, 12 by d square. Okay, 1 multiply with x square plus 3xy. So x square plus 3xy, then minus minus plus, this minus minus plus 6 d dash. D dash means differentiation of this function. So I can write directly differentiation of this function with respect to y. So that is differentiation of x square 0 with respect to y, differentiation of 3xy, that is 3x. So 3x into 6. Okay, so that is 18x divided by d. So that's why plus 18x divided by d, and now this can be written as 12 by d square, x square plus 3xy plus 18 x square by 2. Okay, integration of x with respect to x. So that is 9. So 9x square plus x square. Now you have 10x square. So 12 by d square, 10x square plus 3xy. Now I have to integrate this function, the whole function, with respect to x 2 times. So that's why first of all integrate this function with respect to x first time. So that's why 10 x cubed by 3 plus 3 x square by 2 y. Okay, and now again integration of this function with respect to x. So I can write 12. Now what is the function? Function is 10 x cubed by 3. So integration of x cubed, that is x raised to 4 by 4. So 4 into 3, 12. So 10 x raised to 4 by 12. So that's why 10 x raised to 4 by 12 plus the second term is 3 x cubed by 3. Okay, so 3 once again cancel. So now you have x cubed y by 2 only. So x cubed y by 2. So the final answer is 10x raised to 4 plus 6x cubed y. So this is my particular integral for the given example. Okay, and we know that general solution is complementary function plus particular integral. Let's solve one more example. Del cube z by del x cube minus 2 del cube z by del x square del y, that is equal to x square y. Okay, now what is f of d d dash? First of all find complementary function. So f of d d dash, that is equal to d cube minus 2 d square d dash, that is equal to 0. So I can write m cube minus 2m square, that is equal to 0. We know that m is nothing but d by d dash. So I can write m square into m minus 2, that is equal to 0. So what are the roots? Roots are nothing but 0, 0 and 2. Okay, so I can write complementary function, that is equal to f1 y plus x into f2 y plus f3 y plus 2x. Okay, now particular integral 1 upon f of d d dash. So particular integral I write particular integral, that is 1 upon f of d d dash. What is my function? Function is x square y, and what is f of d d dash? Let me show you, d cube minus 2 d square d dash. So that's why d cube minus 2 d square d dash. Okay, so first of all we have to take d cube as a common term. So 1 upon d cube as a common, because I need 1 in denominator. So now I can write here 1 minus 2 d dash upon d, right, into x square y. Now 1 upon d cube as it is. Now this term I can write 1 plus 2 d dash by d plus 2 d dash by d whole square and so on into x square y. And we know that differentiation of x square y with respect to y, only first differentiation is possible. From second differentiation all the terms you will get 0. So from this term all the terms values are 0. So now 1 into x square y, so this can be written as 1 upon d cube 1 into x square y. So x square y plus 2 d dash into x square y. So that means differentiation of x square y with respect to y. So that's why x square only divided by d. Okay, now 1 upon d of x square, that means the integration of x square. with respect to x. So that is x cube by 3. So I can write 2 by 3 x cube. Okay. All other terms are as it is. So this can be written as 1 upon d cube x square y plus 2 by 3 x cube. 2 by 3 x cube. Now integration the whole function with respect to x 1 by 1. So that's why this is equal to 1 upon d square, okay, because I am taking integration with respect to x first time. So x cube y by 3. Here now I have 2 by 3 x raised to 4 by 4. So I can write 2 in denominator. So now x raised to 4 by 6. Now once again integration. So that's why x raised to 4 y by 4 into 3 12 plus this is x raised to 5 by 5. Okay, and in denominator already we have 6. So 6 into 5 30. And now again integration. So x raised to 5 y by 12 into 5 60 plus this is x raised to 6 divided by 30 into 6. So that is 180. So this is my final answer for this example. So in today's lecture we discuss about case 3. Case 3 means f of xy is a polynomial x raised to m into y raised to n. So we complete all the example of case 3. Okay, so up to case 1, case 2, case 3, you have to remember all the formula. What is our case 1? Case 1 is f of xy, that is equal to e raised to x plus by. Case 2 is what? Sin x plus by or cos x plus by. And case 3 is f of xy is a polynomial. Okay, and for a different f of xy, you have to apply different rules. Try to understand very carefully. So thank you.